I think I can safely say that nobody understands quantum mechanics. These words from Richard Feynman, one of the greatest physicists of the 20th century, highlight the sheer strangeness of the quantum world. But could this quantum weirdness extend beyond the microscopic? Is it possible that our entire cosmos operates according to these bizarre principles? Today, we'll explore a mind-bending concept that pushes the boundaries of our understanding. The idea that our universe itself might be a quantum object. This journey will take us to the edge of scientific knowledge, where reality becomes stranger than fiction. The ancient quest for unity. How did ancient philosophers grapple with the vastness of the cosmos? Long before modern science, thinkers across cultures pondered the nature of reality and our place within it. In India, Hindu and Buddhist traditions developed profound ideas about the fundamental unity of all things. Hindu thought, particularly in the Upanishads, introduced the concept of Atman and Brahman. These aren't seen as genuinely separate, but as one and the same. It's as if we are a wave on the vast ocean of reality, distinct in form, but of the same essence. While taking a different approach, Buddhist philosophy arrives at a similar conclusion. It emphasizes the interconnectedness of all phenomena, suggesting that the entire universe is a single, interconnected system. These ancient concepts stand in stark contrast to our everyday experience. We perceive ourselves as separate individuals, navigating a world of distinct objects. But what if this perception is an illusion? What if, at the deepest level, everything is truly one? Remarkably, some of these ancient ideas find echoes in modern quantum mechanics. The quantum world defies our classical notions of separateness. Particles can be entangled across vast distances, influencing each other instantly. The act of observation can affect the outcome of experiments, blurring the line between observer and observed. In a sense, quantum physics suggests a universe that's more holistic and interconnected than we once thought, a view that would have resonated with those ancient Indian philosophers. But if these ideas of unity have such deep roots in ancient wisdom and modern science, why do we often feel so disconnected from the cosmos? How did we lose sight of this fundamental oneness? To answer that, we need to look at a pivotal moment in the history of science, the rise of classical physics and its reductionist approach to understanding the world. The rise of classical physics and reductionism. Picture a universe neatly divided into building blocks, each obeying precise laws. This concept emerged from classical physics, marking a profound departure from ancient ideas of cosmic unity. Instead of seeing the universe as interconnected, scientists began to break it down into smaller, more manageable parts. This approach, known as reductionism, promised to unlock nature's secrets by understanding its most fundamental components. At the heart of this revolution was the idea that the universe operated like a vast, intricate machine, with each part following predetermined rules. This new perspective allowed scientists to predict the paths of comets, calculate forces between objects, and even discover new planets. The triumph of reason over mysticism led many to believe that, given enough time and knowledge, all of nature's secrets could be unraveled through careful observation and mathematical analysis. As classical physics flourished, there was little room for holistic worldviews. The idea of an underlying cosmic unity began to fade, replaced by a vision of a universe composed of distinct, separable parts. This shift was so profound that it influenced fields far beyond physics, reshaping our understanding of the natural world. Yet, as the 19th century drew to a close, cracks began to appear in this seemingly perfect edifice. Experiments with electricity and magnetism revealed phenomena that classical laws couldn't easily explain. The behavior of light proved particularly puzzling, sometimes acting like a wave, other times like a particle. Perhaps the most iconic challenge to classical physics came from experiments that hinted at a deeper truth. The universe wasn't as neatly divisible as once thought. At the smallest scales, particles behaved in ways that defied common sense and challenged our notions of separateness and locality. We'll explore one such experiment in more detail in the next section. As we approach the quantum revolution, we're about to enter a realm where the clear divisions of classical physics blur into a strange, interconnected dance. The quantum world challenges everything we thought we knew about the nature of reality, inviting us to reconsider our most fundamental assumptions about the universe. Quantum weirdness. Reality defies common sense. Imagine a single electron traveling through space, approaching two narrow slits. As it passes through, something extraordinary happens. The electron seems to go through both slits simultaneously, creating an interference pattern on the screen behind. This is the famous double-slit experiment, a cornerstone of quantum mechanics that baffles scientists today. The double-slit experiment reveals the wave-particle duality of matter, a fundamental principle of quantum mechanics. Electrons, typically considered tiny particles, can also behave like waves under certain conditions. When fired one at a time, these electrons still create an interference pattern, as if each electron is interfering with itself. This behavior defies our classical intuitions about how particles should act. But the strangeness doesn't stop there. Quantum mechanics introduces concepts that contradict our everyday experience. Take superposition, for instance. In the quantum world, particles can exist in multiple states simultaneously until they're observed or measured. It's like having a light switch that's both on and off simultaneously, a concept that's hard to grasp with our classical mindset. Then there's quantum entanglement, a phenomenon Albert Einstein famously called spooky action at a distance. Entangled particles are connected in such a way that the state of one instantly influences the state of another, regardless of the distance between them. This challenges our notions of locality and suggests a deeper interconnectedness in the universe. These quantum phenomena are so counterintuitive that even renowned physicists struggle to comprehend them fully. Richard Feynman, one of the greatest minds in physics, once said, "I think I can safely say that nobody understands quantum mechanics." This ongoing mystery highlights the profound departure of quantum mechanics from classical physics. Even more intriguing is that recent research suggests quantum effects might not be limited to the subatomic realm. There's growing evidence that quantum phenomena could influence larger scales, potentially playing a role in cosmic structures. This challenges the traditional view that quantum mechanics only applies to tiny particles and hints at a more interconnected universe than we previously imagined. The concept of non-locality in quantum mechanics further reinforces this idea of interconnectedness. Events at one location can instantaneously influence events at another, transcending classical notions of space and time. This has been experimentally validated, suggesting that our universe might be more holistic than we once thought. As we continue exploring the quantum world, we're left with a tantalizing question. If quantum effects can extend beyond subatomic particles, could they influence larger systems, perhaps even consciousness? This brings us to an even more mind-bending possibility, the idea of a quantum self. Could our very minds be part of a more extensive quantum system? Let's explore this intriguing concept and its implications for our understanding of reality and consciousness. The universe as a single quantum entity. The quantum nature of our universe may be more profound than previously thought. Quantum cosmology explores how quantum effects might have shaped the early cosmos and continue to influence its evolution. This field applies quantum principles to the universe, suggesting that our cosmos is a single, unified quantum entity. One intriguing concept in this realm is the holographic universe theory. It proposes that all the information contained in our three-dimensional reality might be encoded on a two-dimensional surface, similar to a hologram. This idea challenges our perception of space and dimensionality, offering a new perspective on the universe's structure. The wave function of the universe is another fascinating concept. This mathematical description encapsulates all possible states of the cosmos, suggesting that every potential reality exists simultaneously. It's as if the entire universe is in a state of superposition on a grand scale. These theories raise profound questions about the nature of reality and our place in it. Suppose the universe is indeed a single quantum entity. In that case, the boundaries we perceive between objects and even between ourselves and the world around us may be more illusory than we thought. The principle of non-locality in quantum mechanics supports this idea, suggesting that events in one part of the universe can instantaneously influence events elsewhere, regardless of distance. Some theories even propose that our universe might be one of many in a vast multiverse, each representing a different possible outcome of the universal wave function. This concept expands our understanding of reality beyond the confines of our observable universe, hinting at the existence of countless other realities. As we grapple with these ideas, we're led to profound questions about the nature of consciousness and free will. If we're all part of a single quantum system, how does that affect our sense of individuality and choice? Could our conscious experiences be manifestations of the universe observing itself, collapsing its own wave function into definite states? These theories offer a radically new understanding of our place in the cosmos. Instead of being separate observers of an external universe, we might be integral parts of a vast, interconnected quantum whole. This perspective doesn't diminish our individual experiences, but elevates them to cosmic significance. As we transition from theory to practice, we must ask, what does this mean for us in our daily lives? How might embracing this quantum view of reality change the way we interact with the world and each other? The answers to these questions could reshape our understanding of existence itself, ushering in a new era of cosmic consciousness. As we conclude our cosmic exploration, we find ourselves at the frontier of a new understanding. The concept of our universe as a single quantum entity challenges our perceptions and invites us to reconsider our place in the cosmos. This perspective suggests that the boundaries we perceive between objects, and even between ourselves and the world around us, may be more illusory than we ever imagined. The implications of this idea are profound. It raises questions about our relationship with the universe and each other. Are we truly separate from the world around us, or are we integral parts of a vast, interconnected quantum whole? This shift in perspective could fundamentally change how we interact with our environment and one another. As we contemplate these possibilities, we're not just exploring scientific theories. We're embarking on a journey that could reshape our understanding of reality itself. Welcome to a new era of cosmic awareness, where the fabric of the universe and our place within it are more intertwined than we ever dreamed possible. If you're as fascinated by these cosmic mysteries as we are, then you won't want to miss our next video. In it, we'll delve even deeper into the universe's secrets and explore recent discoveries that could revolutionize how you understand the cosmos. Remember, knowledge is our most powerful tool in the vast expanse of the cosmos. So, are you ready to learn the secrets revolutionizing how we understand the universe? Click that video now, and let's continue our cosmic journey together. Thank you for joining us on this cosmic adventure. Stay curious and keep looking up.